Okay, today we continue topic on medical informatics and fourth lecture. So I will try to provide some introduction about statistical methods. So the untitled wrote especially with emphasis on Microsoft Excel spreadsheet, but most of lecture will be correspondent for statistical methods in general and for understanding basic theory, which is actually strongly required if you have aim to use any software, special statistical solution, special statistical packages, or conventional software, especially spreadsheet. If you want to use it for data analysis and statistical analysis, so first of all, we must have understanding about data processing in general, and if we talk about statistics, so we must be clear about usage of statistical methods. I am apologize and keenly ask about your attention. If you come there for study, I try to provide for you some my skills and knowledge. Look like that part of students even does not hear absolutely what I told. I remember that I provide recording and the video will be published on and available on the department account, along with extra sound too. So first of all, very quickly, I passed through first topic about basic calculation. Actually, it should be your background for this course, but sometimes, actually very often, I see on practice that it's required. Then I will concentrate about statistical topic about hypothesis testing and, if possible, correlation and regressional analysis. Not sure that I will be able to manage this last topic about optimal management tasks. So that practically, on practice, this question available, but we are very limited with lecturing materials. Maybe I will continue next. Okay, so first of all, about calculations and some issues I solve very often with students. Every time when we talk about made any analysis calculation with spreadsheet, you must clearly follow spreadsheet syntaxes and spreadsheet rules and requirements. So if we have mathematical formula, it must be converted and translated into something like this one. I am apologize again. How many times I must ask about attention? Are there everybody comes in this room for studying? So I say again, we need to add our mathematical equation into spreadsheet notation, and we must follow spreadsheet syntaxes and rules. For example, function, we must use function with appropriate list of arguments where they could be delimited by different characters dependent to regional settings. Attention, it's also very important and difficult things. Even input, it should be not difficult, but actually it already exists difficult things for some students. Even input of decimal character, floating point numbers could depend to regional settings and decimal symbol, like comma or dot. Same way, function delimiter. There in my slide wrote about comma. Depending to regional settings, it could be semicolon, comma or semicolon, as delimiter of arguments. Other hand, and if we talk about definition of range or set, there we have more clear settings, like colon every time denotes range from starting till to ending list of arguments, and later I will talk about set. So similar way we can combine function in one equation. Pay attention that depending to original settings, part of formula name or function name could be localized. So it could be translated into a local language. Part not, part translated. It's for me, I even can't imagine reason for Microsoft developers why do they did it, but they already done this. Function name could be partially translated into local languages, so you will be dependent to local settings more clearly. An example of different kind of array function which use arguments as array, or array function itself, which will be updated for range of cells instantly. So we have two choices. And arguments. So when you want to provide make calculation, so what you can use as argument? First of all, constants. If no such value never used or used once, so you can put it directly into equation. But most time, its main aim of spreadsheet application is processing tabular data. So if you have data on your worksheet, you must supply this data into equation by using reference. And we have two kinds, relative or absolute reference. So the relative, it's like a combination column labels, row numbers. Absolute reference, it's actually the same, but prepended by $sign. Could be absolute reference for particular cell, first case, and then just for row or just for column. Use it in specific condition. Absolute reference means this bit you will move or copy equation, it will be not updated. Relative reference will be updated when you move it. And more complex arguments, arrays are set. We can denote array as continuous array, so from starting till to end point by using colon. Here is example, when all cells between start and end will be used. Or you can use a semicolon to combine, multiply arrays together, or just list separate cells. If you have array not as continuous sequence, but part place it in different position, okay, you can make assembly. Attention, last option work not in every cases. For example, data analysis tool pack could prohibit to use set or so sometimes require it to use only array, continuous array. Okay, and way to insert function, it's for example, just by typing function name and provided syntaxes like here given, or another way, it's by this function wizard when you can choose function by category, provide argument, and even get some help about if you forget or not sure is it proper function for usage, you can get some help about what is actually do and purpose. So actually it's that things which must be background, but I spent 10 minutes because I have a large number of issues on this. And I again repeat, I strongly recommend to use practical classes material for class 5, where is listed given information about how to make calculation and even provide short reference about common Excel function, commonly used Excel function. Okay, now move into statistical calculation. First of all, again, I assigned that main emphasis will be made, I will make on statistical parts rather than Excel, because every time if you want to perform analysis, researcher must be clear about methods, ways, methodologies, and even technical tools used for this analysis. So, information system, my particular software can give for you just answer quickly and easy, but you are decision maker right now, and at least until now, and you must understand principles how to make analysis. So just remember what is statistics itself as kind of branch of mathematics, which deal collection, organization, analysis, and declaration of and presentation of data, which is collected within some particular human areas of activity. For us, most interesting for sure, medical statistics. So we deal with application statistic methods in medicine and health science. And there, for example, especially in methodology, public health, forensic medicine, clinical research, and so on. And with statistics, we can let's say, multiply characteristics of our data and make assumption and conclusion, and even provide scientific evidence for our assumption, for our conclusion. Within statistics, we very closely and tightly deal with probability. But actually, you should understand that probability itself could be considered as independent scientific probability theory. I'm sorry, students, maybe somebody will provide better explanation. I understand that maybe I'm not every time correct. Yes? Maybe? Yes? No? Who? Maybe you? So again, probability and statistics were tightly related, but so key difference, like with probability, we measure of likelihood that even will occur or so, studied under separate branch of mathematics, probability theory. Statistics related but separate by disciplines. And with statistics, we use probability distribution. Also, we talk about probability that events occur or not. But major things, as shown from this chart, with probability, we have model of behavior of object or process, and we want to predict possible future also. In statistics, typically we have opposite situation. We are collected some data from our experiment, and we want to retrieve, for example, confirmation of our assumption, or we want to retrieve create a mathematical model to even predict future, for example, of our possible cases. Every time when we talk about prediction, for sure it will be with given probability. And here is when we have related statistical probability. Okay. Technically, when we apply statistical methods for our scientific research, for our study, we talk about retrieving of different measures, sample, as well as population characteristics. They are talking about sample characteristics, but if it's possible, if we have relatively small populations, we can retrieve measures for whole population too. Sometimes it's possible. So like population could represent all members in group, and sample, every time for studying, we extract sample subset from population. In general, everything could be population, so as in the population, we can understand not only like country's population, but it could be limited to, for example, city or town, or only our students in university. It's also population for our students of the Ternopil State's Medical University, and even second year students, it also could be seen as general population in particular circumstances, depending to goal of our study, depending to objectives. So population also could be have very different size, from millions to dozens, no matter it's happened. If we can study whole population, if it's too large, for example, or we have only partial access to it, so every time we try to retrieve subset of population, like for example, particular group is subset of foreign students or second year students from Ternopil National Medical University, and so on. So particular group represents subset of population, and it's sample for sure. Of course, design of sample, it's like even separate lecture required, because we must fit strong, if we want to perform statistical analysis, if we want to perform scientific research, our samples must follow like several rules, like representatives, be randomly selected, and so on. Even this pair, even students group not fit this given pair. We have this problem. Okay, with analysis of our data, we also face the next theoretical point, it's variables. So it's kind of characteristics that can form different values from one observation to another. Like even students' marks that they retrieve on practical classes, it's one variable, and marks that you retrieve on exam, it's even another variable, mostly related to previous, but not full. So there we talk about responses, measures not controlled in experiment, and independent variables are also we can talk about measures that can be take different value which subject to manipulation by research. For example, in case of studying, I can update, for example, materials that I provide for you. So I have control over this. Study department could make control over amount of hours of classes, practices, as well as lectures. So it's our independent variable, like course content. And responses dependent variables, like your knowledge that you let's say, which is assessed by marks, that's me, or on exam, for example, via tests being provided. Or in other case, we can make assessment by, for example, treatment, like measure some vital parameters of patient, or we can make control over some chemical process by observing it through time. So in this case, time become independent variable, and some kind of characteristics, or we talk about vital, or we talk about some another chemical compounds characteristics. So all they will be dependent variables, or responses, or dependent variables. So here is next point. What I want to make emphasis for you, it's classification of data type and type of variables, because it's critical and significantly and it's significant and critically important in case of choice of method for analysis. Even if you want to display data with chart, so separation by data types like categorical and quantitative variables and subgroups under both of it, under categorical as well as quantitative, it's important to understand methodologies which could be applied. So under categorical, we are talking about non-numerical data. And here is it's like names of person or places, or for example, even time periods, like some number of weeks or months number. So all these things it's under can be enlisted under categorical variables. Also, like binary value, true or false, it's example of categorical value. Nominal, when we talk about like difficulties of illness or symptom groups, same way ordinal value. And under quantity, so like could be measured and calculated in numbers. We talk about continuous and discrete value. So more detailed about categorical variables or qualitative non-numerical values. So here is given some importance, and we have choice for two groups or more groups, as I talked about. For example, for difference between nominal and ordinal variables, that in nominal order doesn't have any matters. In ordinal, we have order have sense, order is matter. And there actually, so here we have breast cancer, birth order, and attention. Important notice maybe, like your rankings after exam, like letter grades ABC, as well as even grades which I put for you on classes, even me or other teachers puts for you on classes, all are enlisted under ordinal variables. I want to sign these things. Maybe it's not obvious. It's like simple, but it's not obvious for students very often. This Peter, I put number in your class book to make assessment. Is it answer worse or better or good? It's not actually. It's categorical data type and it's ordinal variable. It could not be actually processed in normal way as continuous. Technically, we can do like different calculation about average of marks or so. Even I do it to calculate average for practical skills before exam. But scientifically, it's not absolutely correct approach because it's ordinal variable. And it's issued by expert. Another expert could issue another assessment, so we can't repeat, and even me next time will issue another mark, even for same topic. So, under qualitative variables, we can only partially apply and continue. Under quantitative variables, we could apply mathematical processing or arithmetical manipulation, like counts, time, and so on. For discrete example of discrete continuous variables given, for example, we talk about like discrete numbers. It's given particular value for particular case. For example, here key number of observation of any diseases within hospital or country or city or so on. How many years completed and so on. And continuous variables, most common is time. So we can stop time. It's each next time point. It's continuous and cannot be interrupted. But very often we made a different examination throughout time and made assessment like, for example, ECG or blood pressure or so, something very similar. So when we made recording of such observation, we instantly convert continuous variable to discrete. Once we just recorded some like blood pressure or ECG throughout time, it's turned into discrete value. Particular time point, particular observation value. We can talk about continuous variable like time, but when we made any analysis, it's instantly turned into discrete. Actually, it's not a problem, because same methodologies could be used every time. Just would be fine to understand this point of difference. We can observe continuous variable, but if we want to analyze it, we need to turn it into discrete. So, every time, if we are now closely to statistical analysis, like these things, please check. Every time use common sense. Major problem with any technical analysis. So we have like a lot of capabilities right now to apply instrumental analysis. We can measure a lot. We can use our skills and software solution like spreadsheet, like Excel or any other, to calculate multiply assessments, to calculate different statistical characteristics of data. So we have technical capabilities to collect data and keep it. We have technical capabilities to make multiply calculation. But arise problem that sometimes happens situation when that analysis does not make any sense. So technically we can do it, but no reason to do it. And even our results will be useless. Task 6, I will show on this example. Typically, if you help us, you know. When we can get data, when we can make calculation, and it's useless. We can retrieve absolutely correct result of calculation, but just useless. Because no reason to do it for that particular data in particular circumstances. So that's it. Use common sense. Use your skills of objective area when you make studying to understand and to decide, does it make sense to make this calculation? Because technically, definitively, you can do it. And system like spreadsheet or statistical PCCR will give for you result. That's very often it's useless. Another way, very fine idea to start with visual assessment. It's not precisely, it's not every time reliably, but it's fine starting point if you're not sure what you want to get. From chat, you can, maybe you will have idea what you should do with this data next. So fine idea, started with drawing chart to visualize data and try to imagine possible further steps. Okay, as of about specific statistical representation, here is will be like, for categorical variables, useful is bar on linear chart. For categorical variables, not numerical data. In case, especially if we have independent variable as categorical. Like that example when I'm talking about when students' marks. So independent variables that will be students, their names, for example, or some kind of ID if you want to anonymize data. And such as it's non-numerical categorical value. And also responses, it's ordinal data also, not discrete, not it's qualitative data. Bar chart, most useful. Linear chart partially could be useful too, but bar chart will be more correct in this case. If you talk about special application for continuous variables, so they are given stem and leaf, box plot, histogram. I'm not talking about all possible chart types. I point only about specific statistical charts. For sure, if you want common chart, conventional common chart type to display continuous data, it will be which one? For students who have passed task 6, to practical class 6. Who remember? Conventional chart type for continuous variable. If we have two continuous variables, independent and dependent, both. Scatter plot, for sure. Scatter plot will just display our data as is. Here is given for you statistical charts, which made emphasis on statistical characteristics. Okay. No, with the bar chart should be obvious. We have like bar chart for shock index category, so we have number of patients which get this shock index. No matter, in hospital, maybe in city or in country, it's no matter where it is. And here is like we have observation of it. Two qualitative variables, two categorical variables, one of it, like shock index category nominal and number of patients. No, shock index category it's ordinal and number of patients it's nominal. So useful bar chart. Never mix bar chart with histograms. They are slightly similar, but it's absolutely different in origin. Okay, stem and leaf, slightly outdated method, but useful when you have relatively large, relatively small sample size. It's very easy to depict characteristics of our data series when you put in stem and leaf. So, for example, here is if you want to like get pseudo driving of distribution of age of patient, just use first decade as stem number of decades and number of years after each decades as leaf, and you will get some similar to frequency distribution. Very useful. Again, I sign it if you talk about manual analysis and you have relatively small data set. For large, not working, and it's a slow analysis. Best way this time to use histogram, which represent probability distribution given variables by depicting the frequencies of observation. So major difference here so we have that our data type must be at least discrete. For example, independent variable x-axis, it's something about maybe a report or so assessment, arrivals per minute, or even arrivals per minute of patient into emergency department, for example. No matter. It's clear that it's discrete variable, discrete data type, arrivals per minute. And how often it's happened. So here we have split our, it could be any numbers. We split it into region and calculate how many times it's happened for how often it's happened. In this case, frequency will be continuous variable at all. Okay, to make To summarize with descriptive statistics, I just want to present this chart, which even display not all methods for sample assessment, but only most commonly used. So here is a list of characteristics which could be used to make assessment of sample data. How we can describe our sample data, or population, also possible if we can deal with whole population. So what we can make assessment for? General central tendency. Is it available some kind of midpoint in your data set that's all other data like tied to it? And we have multiplied such characteristics like mean or conventional average, median, mode, geometric mean, and even list could be continued for more rarely things. Quartiles, only one kind of characteristics. Every time we can split our data in 4 quartiles about frequency, how often it happens. Shape, skewness, not only kurtosis could be listed under there, and even several parameters which display deviation of normal distribution curve of ideal case, deviation from ideal case, and variability, different characteristics which describe in different ways describe deviation also from central tendency, deviation from that midpoint. Like range, interquartile range, variance, not deviation, coefficient of variation, and even other, again, list not complete. So question how we can obtain it and how we can use it, and why do we need so much of these characteristics. Again, depending to data type, we can use different methods or different methodology. For example, interval data measure central tendency variation common as describe descriptive statistics. We have interval level data. Data measured through a particular interval, or we can split our observation period into some interval. So central tendency provides single assessment, variation, talk about how widely how it's deviated and far from this particular centralized assessment. When we try to apply some kind of standardization, we combine both central tendency variation data into single description and compare across different samples. So for example, very often we can use when we combine like mean altogether with mean error. It's conventional. Mean error represents variability characteristics. Mean represents central tendency. And so on. When we talk about non-numerical data, like nominal ordinal, more generalized methodology, it's proportion, which common methods describe frequency and compare to a total. So it's example, why do you have calculated rankings after your exams? And why you assigned to rank group like A, B, C, D, E group. So rankings in this case works as proportion and represents some groups students will be assigned to. So here, given definition, what is means like average scores and sample deviation, mid point of scale measures below 50% score perform, and mode frequency current value in distribution. So here is example again with very small sample set, given all this pointed out. And there's also a relation between variables, or sometimes called as X, and what do we have? Scores, number of scores, or sample size. Things when I am very angry and students don't be able to identify it instantly. So number of scores, numbers of observations, sample size. Here is we have variable age as assessment criteria. We have particular sample data with size of 7, sample size of 7, and there we can very easily calculate mean. Okay, question, why even we need multiply characteristics even to make assessment of central tendency? Just because the problem is outliers. So for example, median could be very easily affected by outliers. We have like some sample size, but different representatives. One value absolutely different, and it's actually, as it's so extremely different, 10 and then other 1 to 4, means we have made assumptions, maybe it's incorrect value, maybe it's error, measures error or something similar. But if we don't know this, we can calculate average and we got very different assessment. In contrast, median not depend and more reliable and not could be affected in case of outliers. So this Peter, we have same data samples, we have in our same median value, different data samples in same median value. So just if we compare mean, median, we can make assessment about some characteristics of our sample, about symmetry, about possibility to present outliers and so on. Again, why every time do we need descriptive statistics at all? Because if we deal with relatively large sample size, if we perform continuous and repetitive examination, maybe we can collect hundreds of thousand billion data records. And you might need to replace these data records just with clear short assessment to make conclusion about some general trend and tendency. For example, if you want to examine, is it new treatment that you try to implement better than previous? So you must have some background to compare and prove that it's really true. And it could be maybe required years for observation and thousands of recorded value, or dozens of thousands, hundreds of thousands. We replace it with descriptive statistics, and when you will write a report in World Health Organization about methods, or when you will write your article to present, to publish your achievements, you must provide descriptive statistics for your data. Same way, dispersion or variability. Variation give information about spread of variability for the data value. So here is, for example, we have like multiply assessment, ranges and quartile range, variance, deviation, coefficient of variation, and more. Here is we have two data samples, just ideal normal distribution chart for it, with exactly the same all central tendency value. If we will calculate for this both samples, mean, median, even geometric mean, you will get everything the same. But due to variability, they are not similar, they are different. So we need to combine both this assessment, central tendency, as well as variation assessment, variability assessment. Not only because variation is single parameters, we need variability assessment in general. To be clear, is that our sample data similar or they are different? Because it's actually main question, to provide, to confirm or similarity or confirm difference in our result. Okay, with quartile range, we split our data set in 4 quartiles, and every time 25% of observation must fall into it. 25 number of observation. So how it will be related for value? It's another question. Most time useful assessment method is so-called interquartile range, which show difference between first and third quartile, like between not between general range that you calculate in class 4. It's different between maximum and minimum value. Interquartile range between first and third quartile, so like half of your data sample must fall inside interquartile range. So here is we have, also you can compare general range to interquartile range and get some kind of assessment how it will be related. And very common things, so to summarize, most commonly used descriptive statistics, and if you want to describe your sample data in short, clear way, it's usage again chart. So usage chart again become useful, especially this one things. Box plot. Box plot. So how we can represent their assessment within, like we based on interquartile range, especially assessment of maximum and minimum, also given for us median and percentile first and third quartile percentiles. Instead of median, another approach could be used average with standard error, with mean error, sorry, average, mean, with mean error, instead of first and third quartile. Or sometimes could be used median and standard deviation. So we have like about 3 general patterns to create box plot. Also, as you can see here, show not only real minimum maximum, but assessed, like it should not be expected maximum minimum for your data sample, should not be greater or smaller outside of 1.5 of first or third quartile. If not, like above, we definitely have outliers in our data series, and they actually should be excluded from further processing because they will not provide correct result. So very often, when you will read scientific article, you will see these things. It means once this box plot chart represents single sample data set. Instead of dozens or even hundreds value, we can print this, and it will be clear assessment which data you have processed. If you compare multiply data samples, you must provide several such charts. 2, 3, 4, 5. And this will be enough to prove for scientists what data you deal with. These things. Again, I assign box plot based on descriptive statistics. It's just summarization and graphical representation of multiply descriptive statistics, sample descriptive statistic parameters at a time. So same way we can calculate variance, standard deviation, like average square deviation between individual scores and mean, or standard deviation. But this time calculation, not so easy to be completed manually. For example, I did it when my university time, I did it manually on my classes related to statistics. It's like time consuming. It's a lot of hours of simple calculation required. It's where about 25 years ago or so. So it's not very difficult, but it's just take a long time. So right now, instead of all this calculation, we can just choose function in spreadsheet and got result instantly. Or even we could be more, it could be done more easy. All descriptive statistic characteristics could be obtained with single command in R statistical package, as well as with single menu item in so-called statistical software. Even more easy than in X. But we must understand meanings, what is this, and purpose of usage. So also, again, why do we need different assessment for deviation, for variability? Because depending also you have 3 samples with exactly the same mean, but standard deviation will be varied depending to how data spread within our data set. Actually, honestly, there mode and median also will help, slightly will help. For example, to distinct data A to data C data set. But it will almost not help with B and A. And so on. Okay, again, same way how we can drive it with, how we can make this assessment with assessment based on histogram and standard deviation. So called 3 sigma rules, deviation around the standard deviation. Here, no, about 3 sigma I will talk slightly more, several minutes. From this summarization about also which mathematical notation, statistical notation, could be used in statistical textbook to denote all these parameters, like variance, standard deviation, population, theoretical variance, standard population deviation, and so on. Okay, if we talk about application, I sign. Okay, if you know which kind of assessment you must complete, it's very easy. We take proper function and we provide it with arguments and we get our results. We get our results. Or also we can extend it and try to use like automation tool like descriptive statistic, which I spoken in practice, which I show on practice. Common way it's function, because not or even direct implementation of methodology via spreadsheet formula, because not all assessment automated on the descriptive statistic tool in Excel, and even not even function available not for all possible assessment criteria. So this, if you can't find function, okay, no problem. Take statistical textbook, check formula, and do calculation on your own in Excel. Definitely, you can calculate everything there, everything. Just maybe not everything is based automatically. Okay, now second points, such as our final goal is provide proof of our assumption about, for example, new outcome in treatment, like confirms that we have more effective treatment method, or we have a new application of even known medicine for new specific diseases. So to provide this proof, before we will come directly to hypothesis testing, need to make the assessment about distribution type. So need to make the assessment about, not assessment, it will be done with descriptive statistics, it's already done, but need to make conclusion about characteristics of the distribution. So when we perform listing or functions that show all possible value of intervals of data, and have our group. When we talk about distribution, we must be clearly understand that we are talking about ideal statistic distribution, like normal or so-called binomial distribution, or so on. So it's ideal model. And what you can actually do in real scientific experiment, when you collect some data, we made assessment. Is it our data is similar to this ideal characteristics? Or how far it from that characteristic? So can we decide that we have a model more or less similar to ideal, and what we should do? So here is example, first of all, frequency distribution, when we group our data according to different intervals and just calculate how many values, observed value falls into this interval. With normal distribution, we provide create frequency histogram where value of score is displayed along x independent variable axis, and the distribution frequency of scores we put along in vertical direction, along y action. So that sampling piece interval we identify as x variable and frequency as our representation of our y distribution. So as a result, we can draw something similar to it, but it will be more similar to bar chart. Here is we talk about ideal case. Ideal case. Reality will be, okay, I will back this one. Here is results of real observation, and ideal model. Ideal model given here. And our question is to decide how closely or far our real observation from this ideal model. For example, Every time we try to ask about is it our data fall into normal range or not. And here is like called 3 sigma rule or 68, 95, 99.7 rule. So like our 68% of our observation must fall into 1 sigma interval plus minus sigma plus minus 1 standard deviation from average. 95 must fall into double sigma interval, 2 standard deviation, left and right from center of tendency, and almost everything must fall within 3 sigma. We are talking about that our data could be called distributed normally. Similar to it. Not exactly, but similar. And it's enough proof to continue. Depending to is it found in this rule or not, we will be limited to specific methods for further analysis. So here is that thing which I'm talking about. And as you can see, enlisted major properties of number distribution: symmetric shape, how scores lie above, below midpoint, asymptotic to x-axis, and so on. Mean, median, mode every time the same, and so on. So forth. If in real case, most of real observation it's more or less far from ideal case, and we have left or right skewed data. And for example, skewness kurtosis descriptive statistic characteristic has been used to make assessment how far to make clear, like log assessment about how far our data divided from ideal shape of normal distribution. So within hypothesis testing itself, use it to establish where difference exhibited by random sample can be inferred to population from which sample is originated. So first of all, we want to provide proof that we have difference between our data sample, and is this difference significant or just consequence of individual variability? Because each one patient, each one studied cases have some own individual features. So with hypothesis testing, we want to find answer. Isn't this difference significant or not? If it's significant, we can make projection for duration. We can make this difference, and we can talk that this difference is significant and will be, we will observe the same in general population. Like, is it some students of third year have better marks than students from second year? Or not? Every time, for all students, in all universities. Or just in Ukrainian universities, or so. But we have only like sample data, it's like second year students from Ternopil Medical University. We have sample and we want to make inference for whole population. Here is given some particular requirements for providing hypothesis testing, like random selection of population, underlying distribution the same size sampling distribution, like we must have same distribution for data sample, and so on. Actually, it's very short list of 3 points. It's not enough to make conclusions that we can apply hypothesis testing method, but it's minimal required parameters, minimum required features when we want to make attempt to apply hypothesis testing. Assumption about normality of distribution, random sampling, mutual exclusive comparing sample characteristics, match statistical techniques, and so on. Also, not clear list, but enough to initial study. Again, depending to data type, like interval or ratio data, categorical variable, continuous variable, or discrete variables, we must use so-called parametrical criteria. Sometimes used in another term, parametrical criteria. like test statistics, person correlation analysis, ANOVA abbreviation, analysis of variances regression. Which one of this method must be used? It will be depends to, okay, I will try to provide this slightly minutes later. It will be depend to, for example, sample size or number of samples you want to compare or so. When we talk categorical, we deal with categorical data, nominal, ordinal. So difference of proportion, chi-square, related measures, association must be used. So it's a reason why data type is important. Because we can't use test statistics for ordinal data. Logically, we can. Technically, we can. Technically, ordinal data very often represented by numbers. And we can calculate test statistics for example, to compare average marks of two groups of students. Technically, we can do it. Logically, do it to this definition. We can't. And technically, you got the result, and you can discuss this result. That's a problem that it's incorrect. Let's back to normal order. Okay, now I will try to provide something like step-by-step algorithm in hypothesis testing. So first of all, very raw. And then I will try to provide more details of particular steps. First of all, when we conduct scientific research, we must make assumption about outcome we expect. Again, I want to say these things. Even before you collect data, you must provide possible conclusion. Very often I see this mistake, even for scientists in our university. They collect data, make calculation, and then come to me and ask, what does that mean? It's actually impossible to answer after that. We made assumption at the beginning. We create state of null and alternative hypothesis even before we can try to collect data. So you have assumptions that your new treatment, that you made improvements for treatment method. Okay, it will be assumption for your hypothesis. But it must be sound like given treatment better than traditional by specific condition. We can like reduce recovery term or improve health condition after all, or improve particular parameter, particular vital parameters of human. It should represent objective of your study. Then, if you have collect some data which may prove your achievement, you need to determine, for example, data type, ordinal or continuous, categorical or continuous, and after that you will be limited with particular methods, which useful, previous slide, which useful for continuous above and categorical or categorical below. Then your question will be made assessment about distribution type. Check. Is it your data? In case, for example, it will be specific for continuous or discrete variables, extra check about distribution type. After that, you can compute statistic test it out. So technical things, how to compute it. And then depending of results, significance, statistical test result and significance, you can accept or reject your new hypothesis. Typically alpha level, it's probability margin, it's like 5% maximum 5% for medical and biological scientific analysis, or modern time more often use less value, like 1% or even less than 1%. And significance provide information about how reliable your results, assessment of reliability of your results. Not only value of critical, important, not only critical value, important not computed result of statistical test, but significance of it. It's even most important. Statistical test could provide for your answer as a difference between your samples are reliable or not. Okay, it will be reason to provide, accept or reject null hypothesis. Is it true or not? But significance tell is it your result is reliable. Low significance, we'll talk about that it's maybe difference exists, but we're not sure, it's not reliable. Okay, more detailed algorithm right now, more detailed. Especially more detailed algorithm of like second step. I will provide details for second step. Check data and decide appropriate statistical test. Because it's actually black box, because it's not easy, in fact. So first of all, data type, categorical continuous. If you talk about categorical data, non-numerical, I repeat again. Compare population in group. We have we have 2 or more groups. It must be, for example, used chi-square test. For 2 groups, also frequency tables of frequencies could be used. 2 ways. More complex situation with continuous data, when we have compare median in groups, means or median in groups. So, depending number of variables, 2 or more, we can use and depending to results of assessment of normality, is that we have normally distributed data or not. We can use like parametric or not parametric statistics, like students test statistics or Wilcoxon tests, or for example, for C distribution and more. Analysis of variance or classical laws or even other methods, because not all listed here, this algorithm is not complete. More completed representation is this one, like table. Actually, it's shortened and cut version of table. Full version contains 6 practical viewpoints, 6 common practical problems, here shown only 4, and better version published under practical classes material and in lecture materials given. So like first column, I turned previous algorithm into table. Left column give for us 6, or in this case 4, common practical problem. So you must decide your narrow task, which is similar to which one of this. Second column recommend statistical representation of this task. Third column tell which test you must provide, which condition must be checked before you will be able to choose practical test. As you can see, every time, test about distribution type. Is the data arranged fit normal distribution or not? And sometimes we have extra test about variances. Last column give for you proper method for particular condition. Just simple example. If we have made assessment about that particular medicine could be used for treatment of some particular diseases. Okay, we have one group that's object with illness that cannot be treated with this medicine, and other that will give this medicine. It's like first example, compare control experimental sample. But if you want made conclusion about is it medicine effective in particular condition, So we have assessment of the same group of objects, patients or animals, before and after taking medicine. Is it this medicine provides some changes? I not discuss good and worse, just changes. It will be second row. Compare sample before and after experiment. What I want to sign, choice even of statistical model, not obvious. And my example, it's very easy and clear. In reality, it could be much more complex to determine what real task we want to observe. Especially if we have a related experiment, if we made assessment before and after, but for multiply group. It's become slightly complicated. Why, again, why so difficult? And I signed it, it's not full list. Why so difficult? Because last column, methods. If you check statistic textbooks, it's formula. So you have data and formula, you can calculate it. But if you break these rules, first three columns, value that you will retain after calculation will be useless. It's a very common problem with statistical results when researchers get useless results because reason for usage was incorrect of assessment. I say it very often, too often. And that's also a way to falsificate results of scientific research. First of all, it's adjust sample for our meanings to prove my hypothesis. Second, just use improper criteria. And you will get results that you want, not which is available in reality. Statement of very fine to note that statistical analysis almost every time based on different patterns. So before I show for you patterns for choice of method. Now even hypothesis should be created as pattern. Like every time we must create pair of hypotheses, null versus alternative, and every time they must be spoken about statistical as well as practical meanings. Every time we start with statistics, and they looks like pretty simple, like null hypothesis. Almost every time talk, no difference between like, and then in blank spaces must be name of parameters, like average or variance or so. Alternative will be opposite. There is present significant difference in samples. So there I am talking about like, here is, I'm talking about so-called two-tailed test, like parameters equal or does not equal. Also, we can examine like left or right one-tailed tests. When we want to compare, is it parameters like increase or decay? Is it we have something greater than another, like after you take medicine, some parameters value increasing or decreasing? Again, I'm not talking about is it bad or good. I'm just talking about changes, confirmed changes. One or left-tailed test, so this time no hypothesis even will not be changed. Look at the first row, and only alternative will be changed. Instead of use equal not equal, we talk about less or greatest. And then, if we will try to depict it as distribution type, so here is we have area like area about 5% difference at right side 95. So the area when we have significant change and we can reject null hypothesis. And you can determine and reject null hypothesis. In case of two-tailed test, we split it by 2. And it will be looking for both sides, what's the greatest. And how it can correlate it with practical assessment, with statistical test. So actually reason why we cannot just compare, we are talking about, we are looking for difference between, according to table, we are looking for difference between average or variance. Why we can't compare this value? Because they tightly related to our sample data. Because difference could be depend to individual variability. So as a result, we need that descriptive hypothesis testing criteria like test statistics or ANOVA or any other. And in this way, we can calculate like assessment. Well, check this blue point, test statistics. So here is given here. No, not available. Pointer not available here. So here is, check this picture. Blue dots with arrow given like T, given particular statistical results of test statistics. And if it's foul in rejection area, we talk about that we can reject null hypothesis in favor to alternative. So it will be proof that difference is significant. If not, so we must accept null hypothesis that there is no significant change. And even I still not, no. Oh, sorry, my word about significance is actually incorrect. In this case, we just talk about the difference present or not present. Significance will be assessed later with next parameters. So every time we must check this. We must provide two statements. We must create two sentences. And we need to look for difference in statistical assessment criteria. As we talk about, no matter what we talk about, average, variance, standard deviation, or other. That is given. Okay, next problem with errors, such as question to make all necessary steps to make the assessment of hypothesis testing. It's actually really complicated. Very often happens like pair of errors, called type 1, type 2 error. It's like personal names for these errors. When we reject null hypothesis, but it's true, and we fail to reject null hypothesis, but is incorrect, in fact. So we talk about type 1 and type 2 errors. So here is other, like gray pair of condition, like we are correct, we made correct decision. If not, there we have like, with choice of 4, we have chance to get 2 errors. And it's very critical things. So with one type error, we can speak about presence of difference, but it's actually not present. With type 2, we are talking about like we have no difference, but it's very small, and you can't identify it, and you cannot confirm that it's significant or big enough to care, but sample size was too small, and we can't measure it. So actually, second problem I see very often, because for example, in low resource country, when we can't perform we can't conduct large number of test sequence, we can't perform large number of experiment. Very often I have like try to make statistics when we have like 2 samples, two attempts with 10 samples in each. Okay, we can calculate, like technically we have all what do we have, or all what do we need. We have all data, and we can make tests about normality, we can make statistical tests, but it should be not reliable. And probability of type 2 errors will be very high. Too small data series. Sometimes we have objective reason for this, like new unspecific diseases, like something come from China, called coronavirus or so. Just we have like about dozens of cases around the world, less than 100 about. It's not enough to get significantly proof what's actually happened. We deal with life and death, but we can't be sure about. So if you want for fun depict how it could look like, okay, no problem. It could be seen like this one. But in reality, in reality, when you have only data sequence, only sequence of number, we doesn't have chance to get such easy and fun conclusion as that we made mistake or not. It's question why we need to be true about assessment. And second point, at significance level. Typically, I don't want to provide methodologies how to calculate it, but actually it's really complex, really complex and difficult. So I just want to tell that most of statistical software calculates these parameters and supply it all together with statistical criteria. And it's the reason why I recommend, if you try to use Excel, try to fit with data analysis to plug automation features, because they automatically generate for you significance level. If not, maybe it will be better to, instead of use Excel, definitely you will be able to calculate. But maybe it would be better idea to study some OS and try to use R package, which is free. Just in reason to get instantly all together statistical assessment and significance assessment. Manually got it slightly, take statistic textbook and you will see how to do it. Number of formulas. With significance level, we talk about probability of that conclusion will be incorrect, like previous assessment of test statistics, like presence or absence difference in mean, or Fisher test, presence or absence difference in variances, how they are reliable. If we talk about less than alpha level, our result is statistically significant. We can trust. We will have difference only, for example, in 5 cases from 100. But if P return about 20, 30, means our real results will be different in 20 cases from 100, in 30 cases from 100. If we talk about treatment of cancer, okay, even we can try. If no chance, no other chance. If we can treatment of, for example, flu, I'm sorry, 20% probability of made mistake. Sounds like dangerous treatment methods, and means that medicine not provide enough effectiveness and not confirmed effectiveness in this case. So it means this method, if you will try another 100%, like if P less than alpha, first row, only 5 will be not affected and so will be not work for them. But will not work for 10 in second row. Why result is not significant? Okay, in general, we talk about like how strong our evidence is. Key breakpoint is 5%. Left side from 5%, our evidence, it's enough and strong. Go right, we doesn't have enough evidence to confirm that our hypothesis is true. So I want to say this, I want again repeat this point. Like statistical parameters itself could talk, you must reject or accept new hypothesis, but it will be true only if we have strong evidence at left side from 0.5 significance. If we are at right side, sorry, no enough evidence that it's true. And then actually it not means that you made type 1 or type 2 mistake. It's just third case, like no correct answer, no clear answer. And in real, and especially in real statistical analysis, it's happened quite often that you will get result with significance greater than 5. Yeah, it's like we spend time, materials, spend time in the laboratory, conduct experiment, and then we get the things. Sorry, real science like this. It's like this one. Okay, as of about automation 2, I told in Excel as well as in OpenCalc, or even Google Spread, we can use data analysis toolpath, and we can get. So you need descriptive statistics at all, like assessment of samples. No problem. Descriptive statistics give for you. Also, we have ANOVA variance. We have Fisher test for pair of samples. We have variance. Our full list here. Fisher test for variance, test statistic, paired, unpaired, for independent, equal, and equal variance. Actually, list not very large. So we are significantly limited with methods which is automated by default. Other methods, you can, as I repeat again, definitely can be calculated. You need statistical textbooks to get formulas and then implement into Excel. Another choice maybe would be better to check R or statistics for automation tool. R free, statistics paid. Excel, actually not free. In university you have permission to access Office, but not at all. Google Spread, you will need looking for free extension to implement this. So things which works exactly as analysis toolpath are available for Google Spread. Just need search analysis toolpath for Google Spread and you will get it. Так. Example, how it could be used. Okay, so like we have 5 minutes, yes? So fine to complete this. So the reason why I spend so much time on this theory, maybe it will be not clearly, but it's very hard to present statistical theory within 1 hour. Problem is automation tool in Excel work extremely simple. Like you have calculate test statistics. Okay, you must provide range for 2 variables, your sample data. You need check your alpha level, 5 or less. And you need to provide only where you want to print your result. And you will get like test statistics at right side. If you want before made test for Fisher, like is it variance is statistically equal? Okay, exactly the same dialog, just different title, Fisher test will appear, and you will get result like given there at the bottom at left side. But problem that you must understand what you do. For example, Fisher test. If you want to perform Fisher test and get conclusion, is it variance statistically equal or not? As first variable, you must provide that which have greatest variance. Because Fisher test itself, if you check statistic textbooks, it's difference between 2 variances, like variance wide, greatest variance divided by smaller. Exactly this order. Not variable 1 variance divided by variable 2, no. Greatest divided by smaller. Only in this way, no matter what order of sample you have in data. Greatest divided by smaller. So this way, and Excel itself not perform this check. It's actually very strange, but when you run a Fisher test, it's not check this. It's like very easy to fix, but Microsoft for years don't do it. So you must check where do you have great variance and define order of sample. And you will get result. Okay, how to make conclusion at this result. So here is we have calculated mean and variance result, means and variance value for our sample data. I signed, we can't compare it directly. We must use a Fisher test to make the assessment about is it variance equal statistically, similar, equal or not. Arithmetically, they does not equal, definitely. So no hypothesis will sound there is no difference in variance, they are statistically equal. I signed word statistically equal. Alternative, there is present difference in variance, they are statistically does not equal. Okay, Fisher test value f equal 1.08 and so on. calculated statistical parameters value. Two automatically provide critical. If not, you need special statistical reference table to obtain it according to so-called degree of freedom. Okay, you have critical value. Our calculated value is less than critical. In this case, if calculated less than critical, we must accept null hypothesis. Again, which sounds there's no difference between variances. But check that p-value, 0.44. We have 44% probability of mistake. So we can't accept null hypothesis, and we can't reject it. We doesn't have enough evidence to make conclusion. We do everything correct, but we can't make conclusion. Not accept, not reject null hypothesis. Test just failed. In contrast, test statistics. So here we are looking for difference between mean, between average. Statistical significantly different, not arithmetical. Arithmetical for sure they are different, but for statistics it's nothing. I'm sorry, maybe it's hard to imagine, hard to determine, but it's proper. It's reason. Why do we use assessment criteria? Because we can't compare arithmetical value. Okay, our objective for study, test statistics, is 4.07. That row given. Here is, we have this one. Imagine we are considering only two-tailored test, like hypothesis, null hypothesis. There is no difference between average in given samples. Alternative, there is present significant difference, statistical difference in averages. Two-tailored test. Then we will check the critical two-tailored. 0.48. Our calculated value greatest than critical. Okay, we can make conclusion that we need to reject null hypothesis in favor to alternative. Present significant, statistically significant difference between mean. Check significant to tail 0.30. It's definitely less than 5%. Our result is significant. Our evidence are strong. We have enough proof to provide. So test statistics give for us proof that we must tell us that we must reject null in favor of alternative. Significance give for us enough proof that we are ensured that we are true in this way. Okay, correlation, regression, another question next time. Thank you for your attention.